Question number 14. Adam shot a model rocket into the air and collected data on the height of the rocket in feet and time in seconds since the rocket was launched. The table shows data collected. Use the technology to analyze the data in the table. Determine how many seconds after it was launched that the rocket comes back to the ground. So we have a table. So we're going to go add a table. So again, you should be typing this in with me, not just copying and not just watching. We need to add a table. We're going to type in 0, 1, 2, 4. And then we are going to add a 2, a 105, a 200, and a 260. Again, it is very important to make sure that your data is typed in correctly. If not, you will not get the right thing. If you will notice, we have these dots. I had to scroll to find them. And then the question says that it wants our determine how many seconds after it was launched that the rocket comes back to the ground. So right now we see it going up and we see the curve where it's going to start to fall, but we don't actually know when it hits the ground. So we're going to ask Desmos to connect these for us. And we ask Desmos with a question. The question starts off, why one worm? Why one worm? And then because this is curving back down, that means it needs to be quadratic. And the formula for a quadratic is ax1 squared plus b x plus c. Oh, and that doesn't work because I forgot my 1. The ones on there are going to talk back to your table. Your table says x1 and y1, so your formula needs to say x1 and y1. Now I can see my parabola coming back down. So this is where it starts off on the ground, and it goes up all the way up to here, and then it comes back down on the other side, and this is where it hits the ground. So the question says, how many seconds after it was launched did it come back to the ground? The answer is going to be about 8. And we can say that, about 8 seconds. The height of a diver is modeled by the quadratic function f, where x is the distance from the springboard in feet. The graph of f is shown on the grid. So we have a diver diving off a diving board. What is the domain of f in this function? All right, so we have two different situations. We have x and we have y, where we use the entire graph. And then we also have x and y, where I only use this top quadrant. When do we only use the top quadrant? The top quadrant is when we're talking about real life situations, real world. We have to think very carefully about, does it make sense to go backwards or down? So in this case, it's actually kind of giving the answer away because it's only showing you the part of the graph that is in quadrant 1. So it is not going to be the entire graph, even though the graph would continue going this way and this way. We're not going to use that information. We're only going to use what we see in quadrant 1. Domain talks about left and right. Domain is x, and if we need help, we can say Dr. XY. And when we look at left, how far to the left does the graph go? The graph goes all the way up here. A common mistake is to try to figure out this number on the y-axis. We don't want the y-axis. Domain goes with the x-axis. So we can only get our numbers from the x-axis. So how far to the left? 0. Can it equal 0? Yes, absolutely, because that is where it starts. Then we have our other less than symbol, and this time we're going to look to the right. And this one's not going to be tricky because the farthest to the right, the number is on that axis already, and that goes to 8. Can it be 8? Yes. And that's the height. Looks like where they are actually touching the water. There it is. There is your domain. Last question, number 16. The graph of the quadratic function is shown on the grid to the right. Which function is best represented by this graph? So what we're going to do is we're going to go type stuff in and we're going to go match up dots. You should be, again, typing this in with me. And you can always just hide what you did previously and keep adding down. You don't have to delete as you go. So we have f of x equals, and I'm going to go ahead and copy f of x so I don't have to keep going back to that screen every time. F of x, and we have x squared minus 3x plus 4. All right, so I'm going to zoom back in, and then I'm going to tap on my vertex. Okay, and we want to try to match it to the graph. This graph has a vertex that's in the top right quadrant, quadrant 1. Now I can go ahead and eliminate that because if you look at your picture, your vertex is lower and to the left. So now let's go type in negative x squared minus 3x plus 4. Okay, and there's your next graph. If you compare it back to your paper, the parabola on the paper is pointing up, and this one's pointing down. So I'm going to hide that one and go type in my next answer and see if that one's going to work. Negative x squared plus 3x minus 4. All right, so this one is also pointing down, so that one's not going to be correct. And we could have realized that from the beginning because it started off with a negative and we know it's pointing the wrong way. And so maybe we wouldn't have even had to type that one in. All right, so it's got to be this one. So let's cross our fingers and hope it comes out the same. And now let's actually go compare some points. Okay, so does it cross at 0, negative 4, your y-intercept? Let's go look. So we think it's going to be this one because these graphs are going upside down. They're wrong. This one had your vertex up in the top right quadrant. So we think it's D. So did it cross at 0, negative 4? Yes. Now let's go check this dot next. That one looks pretty easy. Okay. So let's go check to see if it crosses at a positive 1 on the x-axis. Does it cross at a positive 1? Yes. And then let's go check this one. Does it cross at a negative 4 on the x-axis? Did it cross at a negative 4 on the x-axis? Yes. So by checking a couple of those points, we can see that answer choice D is correct.